Hi, welcome to Module 5, Introduction to Sensors. My name is Joshua Marshall. Okay, in this lesson we're going to learn how to classify different types of sensors, and we're going to identify sensors that are used in particular in mining applications. All right, here we've got an ST14 scoop tram or an LHD, a load haul dump machine used in underground mining. And this one here has been, well, it's a schematic, and it's been equipped with some sensors that are useful for automation. So you'll see the yellow boxes here. These yellow boxes contain laser scanners, so that scan the environment around the vehicle. Those are useful for navigation. Of course, in underground mining, we don't have access to satellite-based GPS, so we need some other way of navigating. We'll talk about that a little bit later in the course. We've also got a little unit down here, which is actually a hinge angle encoder. So you'll recall that these vehicles are articulated. So we'd like to know what's the angle of articulation. So we'd like to use that for our control algorithms and for our navigation algorithms. It's got some other stuff on it. There's an IMU here, an inertial measurement unit that's used for measuring accelerations and for angular rates, for example, using gyroscopes. There's a few other things on this machine. We'll talk about those a little bit later, perhaps, but those are the key components that I wanted you to know about from this slide. Okay, so we've got a little bit of an introduction to the kinds of sensors that might fit on an underground mining vehicle, but there's a whole host of sensors that might be available to us. And we'd like to kind of classify them, and this classification is useful to help us choose the sensors we might need for our particular application. So I'm going to start here with proprioceptive versus exteroceptive sensors. So proprioceptive sensors are the kinds of sensors that we use to measure information that's internal to the vehicle or the machine. So for example, you might be interested in measuring the wheel speed, the steering or joint angles, as we talked about on the previous slide, maybe the battery voltage or the engine RPM, hydraulic cylinder pressures, for example. So perhaps those things are related, that we need to know something about the engine RPM because those affect the pump that controls the hydraulics of the machine, and the hydraulics, of course, control the motion. Okay, so that's proprioceptive sensors, measure information internal to the vehicle, in contrast to exteroceptive sensors. So these are the ones that measure information external to the vehicle or the machine. So things about the vehicle's environment. Things like distance to the objects or walls. So we talked about laser scanners on the previous slide. So that would be a sensor that measures, for example, the distance to walls at various angles. The light intensity, so maybe you have a camera that measures the light coming in. Maybe you're outside and you want to measure the position of the sun. Maybe that helps you in some way, or you're doing mining on the moon, and that would help you to navigate. The position of satellites, of course, for GPS, or maybe Wi-Fi signal strength could be used. So these are all exteroceptive pieces of information, and so these kind of sensors we would classify as exteroceptive. Okay, we can also do a different kind of classification. We can think of passive versus active sensors. So this one's fairly obvious, but passive measures environmental energy. So things like a camera, for example, use light from the environment. The light acts on the camera, and the camera records that information. As opposed to, for example, an active sensor, which measures something, emits something into the environment, and then measures how that emitted energy changes or bounces back, for example, to some sensor on board the vehicle. So things like a laser scanner that are active send out light and see how that light reacts using another sensor. Sonar, for example, sends out a sound wave and measures the time it takes for that wave to reach it again to estimate distance. So here we have passive versus active type sensors. It's kind of useful to understand the difference because these, again, like I said, these kind of classifications can help us to choose what kind of sensor might be appropriate for the given environment. So let's test yourself for a second here. On the figure on the left, we've got a trailer equipped with some sensors, a whole host of things. If you really want to get picky here, we can look at, there's some laser scanners. This on top here is an RFID tag reader, so it can tell if it's near a certain tag, what that tag number is. But in particular, what I want to point you out to here is that inside the wheels of this particular sensor, and this one's being used underground, or this particular vehicle, sorry, this one's being used underground, is an encoder, and it's measuring the wheel rotation. So would this be proprioceptive or an exteroceptive sensor? Of course, we're measuring information internal to the vehicle, so a wheel encoder would be a proprioceptive sensor, right? Would this be active or passive? Well, in this case, it would be passive. We'd be using energy from the rotation of the wheels to then turn the encoder, and the encoder would record some message. On the right, we've got a Kubota front-end loader, which is equipped with a GPS antenna here at the top. There's two of them, in fact. But here we're measuring signals that are coming from satellites and using those to help navigate or position the vehicle in space on the Earth. So proprioceptive or exteroceptive. In this case, exteroceptive sensor. We're measuring something external to the vehicle. Active or passive. Again, in this case, we have, in some sense, a passive sensor. It's measuring information from the outside world. Of course, you need to power your unit. But that's beside the point in this case. Okay, let's think back to our ST14 vehicle here. We've got a few sensors that I mentioned. We have laser scanners on board, and we've got a hinge angle encoder and an IMU. So I'd like you to think about this vehicle and decide what you think. Are these, which of these is active and which of these is passive? Which of these sensors is proprioceptive and which is exteroceptive? Here we go. We've got our laser scanner, clearly emitting light into the environment, so it's an active sensor, and measuring information about the outside world. So this is an exteroceptive sensor. Here on the right, you can see a sort of top-down view. Here's what the laser scanner sees in this picture. So we've got our sensors. There's two of them, one on the front and one on the back. You'll recall from that schematic on the previous slide. One's measuring the back here, and you can see the profile that provides here. We've got a whole bunch of little laser scans. We connect the dots, and we can see what's going on. It's kind of handy if you're teleoperating this machine, you can imagine. And on the front, likewise, we can see the tunnel drift. So here you can see a camera being used. So there's a camera here up in the top of this little yellow box, and this camera is being used to provide some information to a teleoperator. So this camera is a passive sensor. It uses light coming into the sensor, and we can display that here to the operator. And of course, this is an exteroceptive sensor, measuring something about the outside world. I'd like to leave you with just a quick shot here of a trailer being pulled. Here's our encoders here on the bottom of this trailer again. And you'll notice that we've got some sensors here that are passive. So we've got some cameras here, and we're attempting to do some mapping on this vehicle here underground. It's a dark environment. Typically, there aren't lights. And so we've had to add lights here to this trailer to get enough light for those cameras to be able to register any information about the environment. So clearly, here's a situation where you want to consider strongly the case for passive versus active sensors in a given application. If you've got a passive sensor and it's not going to work in that particular environment, you may need to add some active components to make them work.